Hi everybody, this is your week 4 and you're going to do probability this week. Okay, so what are the learning outcomes? By the end of this week, you should be able to define probability. You should be able to distinguish between the different types of probability. You should be able to recognize the various terms used in probability. Yeah, okay. So let's see what is probability first. Okay. So in our everyday life, we constantly assess the situations based on the probability of things happening around us. Isn't it true? While you step out of your house, you make a decision. Are you going to wear a coat or not? Or you will make a decision. Are you going to wear a rain jacket or a winter jacket, a snow coat, based on whether it's going to rain or whether it's going to snow? Or if it's going to be sunny, then you don't need a coat. So all this is based on some decisions you make based on probability, isn't it? Similarly, crossing the road, you make decisions. Is it safe to cross the road? And it is based on probability. Eating at an unknown restaurant, my favorite example. A holiday, I think, that is successful when you eat at the best place. If you have enjoyed the food on your holiday, I feel that that holiday was my best holiday. Okay, so that is again a probability. Is it going to be a best holiday? Yeah. Okay, and another example is gambling at a casino. Are you going to win or are you going to lose all the money you have? Okay, sorry. Betting on a horse. Is this horse going to win or lose? Buying a ticket for the national lottery. I never take a lottery because I never win. So maybe I should try my luck. I don't know. Again, that is probability. So what is probability? What do you think? What is probability? We make decisions based on our experiences, intuitions, and sometimes it may even be at a calculated risk, isn't it? Yes? So what is probability? These are all decisions which we make based on our experiences or feelings or intuitions, yeah? And sometimes like taking a lottery ticket or betting on a horse could be a calculated risk, yeah, or getting drenched, going out without a coat. Yes. So now can you think of some good examples of probability? Thank you. Good. So there are 3 different types of probability: empirical, judgmental, and logical. As the word indicates, empirical means the probability which is based on observation. What are the odds that the next baby born is a boy or a girl? Okay. Judgmental, again, as the name indicates, you make decision based on some feelings or experiences, like what is the probability that horse number 7 will win the next horse race? Yes. And then you have the logical probability based on some mathematical theory. Yes. Like what is the probability that the next card picked at random from a pack of cards is an ace? Okay. And this probability, logical probability, can be quantified on a scale from 0 to 1. Yeah. So if there are 50% chance that you're going to pick an ace, which is not going to happen actually, yeah, then you say it is 50% of 0.5, or it may occur or may not occur, yeah. But if there is 0 probability, then it is impossible. And if the probability is 1, that means it's certain, which is unlikely to happen in a real world. Yeah. So as you go towards 1, it is more likely to happen. And as you go towards 0, the event is more unlikely to happen. Oh my God, I've used the term event. We're going to see what is event soon. If you toss a coin, you cannot get both a head or a tail at the same time. Okay, so the probability of this happening is 0. Okay, So that is a good example of something impossible. Yeah, an event happening where the probability is 0. Yeah. Okay, again, so these are the most commonly used commonly used items, I should say, for in probability problems like the coin, the dice, the letters, or the cards. So you should be familiar with the possible outcomes of these examples. Okay, so let me go through each one quickly. A normal coin has two sides. One side shows a head and the other side, which doesn't show a head, is the tail. Okay, so you should be familiar with this term, head and a tail. Okay, and then you have the cards. Okay, a normal pack has got 52 cards and it has got 4 suits. Okay, and there are 2 red suits and there are 2 black suits. Of the red suits, you have hearts, red colored hearts, and the red colored diamonds, and the black colored are spades and clubs. And there are 13 hearts, that's why I've said 13 cards in each suit, 13 diamonds, 13 spades, 13 clubs. So totally how many cards are there? 52, isn't it? 4 times 13 is 52. And these 13 cards have 1 ace, 2, 3, 4, 5, 6, 7, 8, 9, 10, and then a jack and a queen and a king. Okay, so you should be familiar with these cards. If not, please let me know in the seminar. Okay, then a traditional dice. Yeah, most of the problems use traditional dice. Yeah, a single die. A die has 6 sides from 1 to 6. Okay, and the letters, everybody knows there are 26 letters in English. Okay, and you should know about the consonants and the vowels. Okay, now we have seen what is probability, we have seen the different types of probability. Now let's get familiarized with these terms, which are often used in probability problems. Okay, so we use the word process to refer something that has a number of outcomes. Okay, for example, let's take the coin example. Yeah, for tossing a coin has outcomes head or tail. So the process here is tossing a coin, isn't it? That is the process. That is the process which is happening. And the outcomes are you could get either a head or a tail. So these are your outcomes. So when you toss a coin, you may get a head or a tail. And we use the word event to refer to getting a specific outcome of the process. Okay, so for example, if you want just the head to happen, yeah, getting a head with the toss of a coin, so that's the event. The process is tossing the coin, the outcomes could be head or tail, and the event is getting a head with a toss, with one toss of a coin. Yeah, so that is the process. Then that getting a head or a tail is the outcome. And if you're particular about an event to happen, then for example, in this case, getting a head with a toss, that is the event. Okay, so now several outcomes of a process may cause an event to occur. Okay, for example, obtaining an odd number with the single throw of a die. So single throw of a die, that is you're throwing the die only once. That is the process. And obtaining an odd number is the event. Okay. So single throw of a die, that means you could get 1, 2, 3, 4, 5, 6. These are the possible outcomes. Yeah. But you want to get an odd number. So that means possible outcomes of this event is 1, 3, 5. Because there are only 3 odd numbers there, 1, 3, 5. Yeah. Okay. Now let's see the term random. Yeah. So when we toss a coin, for example, there are 50-50% chance that it could be either head or tail. Okay. You cannot say whether it's going to be a head or a tail. It's not in your hand, yeah? So it could be a head or it could be a tail. So the outcome of the process is said to be random because you are not sure whether it's going to be a head or a tail. It's not in your hand. It's not certain. It is not certain. It's a random process. So this process is called random and the outcome is therefore said to be random. Okay? Because the outcome is not certain. Similarly, if you throw a single dice, there is an equal chance that you'll get 1 or 2 or 3 or 4 or 5 or 6. It is equally likely that you will get any one of these. So the process is random. Yeah. So in general, if the outcomes of some process are equally likely, the probability of an event occurring is given by probability of an event is equal to number of outcomes that causes the event by total number of outcomes. Just let's take the dice, which we were talking about. Probability of getting an odd number, probability of getting an odd number, which we just saw. What is the probability of getting an odd number? Why don't you find that, please? Use the formula and figure it out. Okay, good. So here, what is the total number of outcomes? It's a dice. So there are 6 numbers. So there are 6 possible six possible outcomes. Yeah, so total outcomes will be 6. But the event is one odd number. Okay, probability of getting an odd number. So you could either get 3, you could either get 1, you could either get 5. So there are 3. These are the equally likely possible outcomes to get an odd number. So there are 3 possible ways you can get an odd number. There are 3 possible ways you can get an odd number. So number of outcomes that cause the event is 3 and the total number of outcomes are 6. So 3 by 6 is 1 by 2 for this example. Okay, good. Now, I want you to try this now. A normal fair coin is tossed 9 times and 9 heads are obtained. What is the probability that if the coin is tossed a 10th time, it will be head? Good. It is half or 0.5 or 50-50 chances. Good. Yes. So there are 50-50. You are not sure. It could be, it's the 10th toss. 10th toss is independent of all the tosses which has happened. They don't depend on that. Yeah. So it could be head or it could be tail. So it's 50-50% chance. Or if that's in fraction, so this is in decimal. Yeah, or I can also give in percentage. So probability can be represented in a fraction or decimal or percentage. Okay, now this question. What is the probability of selecting a picture card from a normal pack of cards? You can use the formula here. Good. 12 by 52. Yes. So how did you do that? Yeah, you can simplify it to 3 by 13. It's good. Probability of selecting a picture card is 12 over 52 because their possible outcomes are 52, but you can, how many different ways can you pick a picture card? There are 12 different ways you can do that, 12 possible ways to do that. So 12 by 52. Okay, good. Now you know what is process, outcome, event, random. Let's see what are independent events. Okay. Okay. When we toss a coin more than once, each time we toss it, the outcome is random. Just now we've seen it. Yeah, we have seen that if you toss a coin, this is a random process because the outcome is random. You could either get a head or tail. Yeah, it's not certain. Okay. Similarly, you toss again. You could either get a head or a tail. It's random. It's not in your hand. It's not certain. Yeah. So this event, the second event, the second toss, the second event is independent of the first event, the first toss. It doesn't matter whether you got a head or a tail in the first event. Yeah, you can get head or tail. It doesn't matter. This event is independent of this event. It doesn't matter. Okay. The outcome of the second toss is not affected by the outcome of the first toss. Likewise, the outcome of the third toss, to toss again, it's not affected by the outcomes of any of the previous two tosses, and so on. You toss again, it is not dependent on the tosses you have already done. So what does it mean? We say that the individual tosses are independent of each other. Each event is independent of each other. And tossing the coin is the best example for independent events. Okay, so we have a formula here, independent events. Okay, let's see this. Yeah, because the coin is the best example for independent events, we are going to stick on to that. Yeah, we have already seen that the repeated tosses of a coin are independent of each other. If we throw a die and select a card from a normal pack of playing cards, these are independent processes, and these two events are independent because the outcomes of these two events are independent. That is, you throw a dice and you pick a card randomly, throwing a dice and picking a card randomly. Yeah, this event does not stop this event from happening. Yeah, so that's fine. They're independent process. They're independent events. Yes. Okay. So when two events are independent to each other, probability both event occur is probability of first event occurring times probability of second event occurring. Okay. Now, a coin is tossed 3 times. Okay. 1, 2, and 3. Okay, let me show again. What I want you to understand here is a coin is tossed 3 times. I toss once, then I toss one again, then I toss again. So in the first toss, I may get head. In the second toss, I may get head. In the third toss, I may get, this is a probability, I may get head, okay? But it is possible that I may get head in the first toss, second toss head, then tail. It could happen. In the third toss, I may get head, tail, head, head, tail, tail. There are different possible ways. So how many outcomes are there? 1, 2, 3, 4, 5, 6, 7, 8. There are 8 possible outcomes. Anything could happen. Yeah. So the total outcome is 8. Yes. Now, if I ask you, what is the probability that 3 heads are obtained? There are total 8 of, I can use the same problem, but formula, and then try to figure it out. Yeah. Good. That's right. So it's 1 by 8. Very good. The total outcome is 8. Probability that you will get all 3 heads is, this is the only possible way you can get that. Can you see? There is no head anywhere. This is the only possible way you can get that. So 1 by 8. There is only one possible way this event will happen. So 1 by the total outcome, which is 8. Okay. Now, what is the probability that a head is obtained on a third toss? Again, look here. If you look at this, what is the probability that a head will occur? Let me rub this all, then it will, yeah. So you want a head in the third toss. So there is a head, because that's my first toss, my second toss, and my third toss, okay? And then I have head, and I have head. So 4 ways, there are 4 ways by which I can get it. And total outcome is 8. This means 1 by 2. Yeah. So 50-50% chance. Good. Okay, so now we have seen what is independent event. Now let's see what is mutually exclusive event. Yeah, what are mutually exclusive event? When events are mutually exclusive, if one event occurs, it prevents the other event from occurring. That is, when one event occurs, it prevents the other event from occurring. For example, getting a queen and an ace with a single selection of a card from a pack. So you pick only once and you need to get a queen and an ace. That's impossible, isn't it? Yeah, that is impossible. So then the two events are mutually exclusive. That is, if you pick a queen, you will not get an ace. If you pick an ace, you will not get a queen. So they are mutually exclusive events. That is, picking an A stops the queen to happen. That is, stops the queen to be seen, or stops the queen card to be picked, or picking a queen stops the ace card to be picked. So they are mutually exclusive events. So probability of both event occurring, that is both queen and the A to happen, is 0. It cannot happen. It is impossible. So mutually exclusive events are events that are impossible, that is, that prevent one event from happening. Yeah. So if one event occurs, it prevents the other event from happening. That is impossible. And the probability that both event occurs is 0. Okay, let me get this out. Yeah. So why don't you answer these questions? Yeah, read this carefully and click in your answer there. Yeah. Excellent. Very good, guys. Yeah. Okay. Now, let me go. Yeah, we have seen mutually exclusive events, independent events, and all these terminologies. Now let's see what is conditional probability. Okay. To understand this, let's take this, consider this bag containing 3 green balls, 2 red balls, and 1 blue ball. Okay. So you have 3 green balls, 2 red balls, and 1 blue ball. Totally, how many balls are there? We have 6 balls. Okay, we have 6 balls. Now what I want you to do is pull 1 ball at random from the bag and then pull a second ball by replacing the first ball. Okay, guys, by replacing the first ball, you have to replace the first ball. Let me show you how we do that. Yeah, determine the probability for each of these outcomes. Okay, let's do that together. Yeah. Okay, so first ball I pick is a green ball. What is the probability that the first ball I picked is green? Good. It is 3/6 is equal to 1/2. Now, I pick another ball and that's going to be green. What is the probability that I pick the second ball is green? Remember, guys, I am putting this ball back again. I put this ball back again and then I pick the second ball. Okay. So what is the probability of picking a second ball? Picking a second ball that is green, it is 3/6 again, because you have 3 balls again. So 3/6, which is nothing but 1/2. Okay. What is the probability that both events are happening? That is, you pick the first ball picked is green, then the second ball picked is green. It's going to be the product of the 2 balls. Yeah. So 3/6, half times half, which is 1/4. Yeah. Okay, now I pick a green ball. So what is this is a different event. Okay, that's your first. Now it's second. I'm picking 2 balls again. I pick a green ball first, then I put that back again, and then I pick another ball. Okay. So what is the probability that I pick a first? I pick the first ball, it's green. So there are 6 balls, total outcomes is 6. There are 3 possible ways I can pick a green ball. So 3/6 again. Okay. Now I put this green ball back and then I pick a red ball. Let me rub this all so that we don't get confused. Okay, now I pick a red ball. So total balls, total outcome is 6 again because I put this back. Remember, I put this back and then I picked it. So there are 6 balls, but how many ways can I take the red ball? 2 ways. There are 2 possible ways. So 2 by 6. So 1 by 3. So probability that I'll pick a green ball first and then a red ball second will be 1 by 6. Good. Okay, now let's take another possibility. Yeah, I pick a blue ball. So what is the probability that the first ball I pick is a blue ball? Yeah, total balls 6. Yes, there's only one way this is going to happen. So 1 by 6. Now I put this ball back and I pick a blue ball again. So what is the probability that the second ball I pick is a blue ball? Good. Very good. That's right. It is 1 by 6 because I put this ball back and then I have replaced it. And the total number is 6 again. So it is 1 by 36. Now, let me take a new process now. Okay, each time I'm rubbing it because I don't want it to come, because it's fresh again, yeah? Okay, now I pick a green ball. What is the probability that I pick a green ball first? Good. It's going to be 3 by 6 is equal to 1 by 2. Now I pick a blue ball. What is the probability that I pick a blue ball the second time? Remember, I am replacing this. Okay. So what is the probability that I get a blue ball? Good. It is 1 by 6. So the total probability is 1 by 12. Now, what is the probability that I pick a blue ball? Good. 1 by 6. What is the probability that I pick a red ball? Remember, I have replaced this ball. So what is the probability that the second ball I picked is red? Good. And what is the probability that I pick a blue ball and then a red ball? Okay, by replacing here. Okay, good. Now, what is the probability that the first ball I picked is not blue? Good. 5 by 6. Now, I replace whatever ball I picked here. Then what is the probability that the second ball I picked is not blue? Good. 5 by 6. Now, what is the probability that I picked a non-blue colored ball and then a non-blue colored ball by replacing? Good. That's right. Very good. So you got it. So when probability is not affected by a previous event because you're replacing it, then this is how you calculate the probability, and this is what you have seen. But now let's change the question. I'm going to pick the first ball, but now I am not going to replace the first ball. Then what will happen to the probability? Let's see what happens to the total probability. Okay. Okay. So we're going to do the same thing and find the probability now. Okay. So that's going to be same. I picked this green ball. So there is 50-50% chance that the ball is green. Okay. Okay. Now what if I pick a green ball again? What is the probability that the second ball is green? Remember, I am not going to put that back. It's outside. It's gone. It's gone. It's gone. Now you don't have a green ball. So what is the probability that the second ball is green? Can you think about it? Good. It is 2 by 5 because you have only 1, 2, 3, 4, 5 outcomes now, 5 balls to be picked. I mean, 5 possible outcomes. And there are only 2 ways you can pick the green ball. So it's going to be 2 by 5. Now, what is the probability that the first ball you picked is green, then the second ball you picked is green? It's going to be, yes, 1 by 5. 1 by 2 times 2 by 5 is 1 by 5. Good. Now again, what is the probability that the ball I pick first is green? Good, it is half. What is the probability that the second ball I pick is red? Remember, I have not replaced this ball. I'm not putting this ball. So that one ball is gone. This green ball is not there. So what is this probability? The total, yeah, good. So the total balls is 5. The possible ways you can pick the red ball is 2 ways. So it is 2 by 5. And what is the total probability? Good. Again, now let's do another one. I'm going to erase this. What is the probability that it is blue? The first ball I picked is blue. Good. What is the I don't replace it, okay? It's gone. It's gone without replacing. What is the probability that I pick a blue ball again? Good. Now, how many balls are there? Total balls 5. And how many different ways can you pick a blue ball? 0. So it is 0. What is the total probability? Yes, it is 0. If this is not possible, yeah, because there is no 0 ball for the second time to be picked, yeah. Okay, now, what is the probability of picking the green ball? Good. What is the probability that I pick a blue ball? Good. What is the total probability? Yes. Now, blue ball. Good. Red ball. Remember, guys, without replacing. I don't put this ball back. You don't have the blue ball. Good. What is the total probability of this, of picking a blue ball and then picking a red ball without replacing? Good. Now let me erase this again. What is the probability that I don't pick a blue ball? Yeah. And then again, I don't pick a blue ball. Be careful here. I am not picking a blue ball. And then again, I'm not picking a blue ball. Good. That's right. Very good. So total probability is 2 by 3. Okay. So now look at that. The probability has changed. If you pick a green ball, it is half. But if you pick a green ball, the second time it is 2 by 5. It has changed, you see. So in the previous example, for example, in the previous example, here you've seen that, okay, so you've seen that the probability is going to be same, half, half, yeah? But here it has changed, yes? Let's quickly put it, yeah. It's changed, yeah? It is not the same. The probability of picking a green ball is affected, probably picking a green ball the second time is affected by the first event. So this event is affected by the first event. This event, happening of this event is affected by this event. Happening of this event is affected. You can clearly see it is the probability 0, but it was 1 by 6 in the first event. So this event has been affected by this. So that is called conditional probability. It is called conditional probability because this event is dependent on the other event. Okay. So now I want you to, now since you have seen the different terminologies now, I want you to read this question carefully and identify which are independent events, mutually exclusive, and which are neither. Choose your answer on this right side, guys. Thank you very much. Okay, so that's all for part 1. We will meet again in part 2. Thank you, guys.